In this video, we're going to talk about how to solve absolute value equations algebraically. So what is the absolute value? The absolute value tells you the distance of a number from 0 on the number line. So the absolute value of a positive number, like 3, is going to be equal to 3 because 3 is 3 units away from 0 on the number line. The absolute value of a negative number is going to be the opposite. So like the absolute value of negative 4 is going to be 4 because negative 4 is 4 units away from 0 on the number line. The reason for this is because distance is always going to be a non-negative number. The absolute value of 0 is going to be 0 because 0 is 0 units away from 0 on the number line. So we can keep this idea in mind as we're working on solving absolute value equations. Say we have an absolute value equation like the absolute value of x is equal to c, where c is a constant. We're going to have 3 different cases depending on the value of c. If c is a positive number, we're actually going to have 2 cases. Because if you think about it, this absolute value of x equals 4 is saying, well, what are all the numbers that are 4 units away from 0 on the number line? Well, we actually have 2 possibilities because both 4 and negative 4 are 4 units from 0. So if the absolute value of x is equal to 0, we only have 1 possibility because 0 is the only number that's 0 units away from 0 on the number line. If the absolute value of x is equal to a negative number like negative 5, we have no solution because distance always has to be a non-negative number. So there's no number that's negative 5 units away from 0 on the number line, so if your absolute value is equal to a negative number, you'll always have no solution. So here's what we do to solve absolute value equations. You always want to make sure the absolute value is first isolated using inverse operations. If c is positive, then we're going to separate into 2 parts by setting the expression inside the absolute value equal to positive and negative c. Then we'll solve for x using inverse operations, and you always want to plug your answers back into the original equations to check. An absolute value equation can have 0, 1, or 2 solutions. So let's start off with this example. Let's solve with the absolute value of 2x minus 1 is equal to 7. So 7 is a positive number. That means I'm going to have 2 cases when I'm solving this equation. So I'm going to set it equal to the positive value and the negative value. So I have 2x minus 1 is equal to 7, and 2x minus 1 is equal to negative 7. So now I'm going to go ahead and solve both of these equations. So I'm going to start off by adding 1 to both sides. So that's going to give me 2x is equal to 8. And then I'm going to divide both sides by 2. And that's going to give me x equals 4. So that's my one solution. And then I'm going to solve the second equation. So I can go ahead and add 1 to both sides. And that's going to give me 2x equals negative 6. I'm going to divide both sides by 2. And that's going to give me x equals negative 3. So let's go ahead now and check our solutions. And when we check our solutions and we're solving absolute value equations, you always want to go back to the original problem. So don't check your solutions by plugging into the 2 equations you wrote. You want to go back to the original that's given to you. So I'm going to start off with x equals 4. So that means I have the absolute value of 2 times 4 minus 1 equals 7. Which means the absolute value of 8 minus 1 equals 7. And so that's saying the absolute value of 7 is equal to 7, which is true. If I check x equals negative 3, that's saying the absolute value of 2 times negative 3 minus 1 is equal to 7, which is the absolute value of negative 6 minus 1 equals 7. So that's saying the absolute value of negative 7 is equal to 7, and that's also true. So now you can go ahead and pause the video and try doing these examples on your own. So you can see here we have the absolute value of x plus 9 is equal to 17. So we're going to separate it into 2 cases since 17 is positive. We go ahead and solve, which gives us 2 solutions, x equals 8 and x equals negative 26. When you plug them back in, they both will work in your original problem. So now let's try this example. So here you can see the absolute value is not isolated. We actually have this 2 in front. Okay, so whenever you have something like that, you want to work on first getting rid of that before you worry about the 2 cases and solving and all of that. So I need to get rid of that 2. Well, that 2 is multiplying my absolute value, so the opposite would be to divide both sides by 2. So when I divide both sides by 2, I get the absolute value of x plus 3 is equal to 10 divided by 2, which is 5. Since 5 is positive, now I can separate into 2 cases because I have the absolute value isolated. So I have x plus 3 is equal to 5, and x plus 3 is equal to negative 5. So now I'm going to work on solving these equations. So here I'm going to subtract 3 from both sides. And that is going to give me x equals 2. And over here I need to subtract 3 from both sides. and that would give me x equals negative 8. So now I'm going to go ahead and I'm going to check my solutions. So I'm going to start off with x equals 2. So I plug back into the original equation, okay? So I have 2 times the absolute value of 2 plus 3. We're checking if that's equal to 10. So that's saying 2 times the absolute value of 5 is equal to 10. And 2 times 5 is equal to 10, so that will work. Now let's try x equals negative 8. So that's 2 times the absolute value of negative 8 plus 3 is equal to 10. So that's saying 2 times the absolute value of negative 5 is equal to 10. 2 times 5 is equal to 10. So this solution is also going to work. So now let's try this example. So this one's a little bit different because now we just don't have a coefficient in front of the absolute value. We actually have this 3 also. So whenever we're working on undoing these operations, I'm going to do the opposite of the adding or subtracting before I do the opposite of multiplying or dividing. So here I'm going to start off by getting rid of that 3 by doing a minus 3 on both sides. And so that's going to give me 4 times the absolute value of 5x minus 2 is equal to 32. And now I need to get rid of that 4 by dividing both sides by 4. And so that's going to give me the absolute value of 5x minus 2 is equal to 8. So 8 is positive and my absolute value is isolated. So I go ahead and separate into two cases. So I have 5x minus 2 is equal to 8. And 5x minus 2 is equal to negative 8. So now I'm going to solve these equations. So here I'm going to add 2 to both sides. And so now that is going to give me 5x equals 10. I'm going to divide both sides by 5. And that's going to give me x equals 2. So there's one of my solutions. Over here, I'm going to add 2 to both sides. And that's going to give me 5x equals negative 6. And then I'm going to divide both sides by 5. And that is going to give me x equals negative 1.2. So now I always need to go back and check my solutions to make sure that they work in my original equation. So if I check x equals 2, I have 3 plus 4 times the absolute value of 5 times 2 minus 2. And I'm checking if that's equal to 35. So I have 3 plus 4 times the absolute value of, let's see, 5 times 2 is 10. 10 minus 2 is 8, so that's going to be the absolute value of 8. I'm checking if that's equal to 35. So that's 3 plus 4 times 8 is equal to 35, which is 3 plus 32 equals 35. So that is a valid solution. So now let's check x equals negative 1.2. So we'd have 3 plus 4 times the absolute value of 5 times negative 1.2 minus 2. And we're checking if that's equal to 35. So we have 3 plus 4 times the absolute value of 5 times negative 1.2 is equal to negative 6. So we have negative 6 minus 2, and then that's equal to 35. So that's 3 plus 4 times the absolute value of negative 6 minus 2 is negative 8. So we're checking if that's equal to 35. Well, this is saying 3 plus 4 times 8 is equal to 35, because remember the absolute value of negative 8 is 8. And we know that that means 3 plus 32 equals 35, which is in fact correct. So both of these solutions are actually valid in our original equation. So now you can go ahead and pause the video and try doing this example on your own. So here we have the absolute value of 2x minus 3 minus 4 is equal to 3. Remember, the first step is to get that absolute value isolated by adding 4 to both sides. That then gives us the absolute value of 2x minus 3 is equal to 7, which we separate into two equations. We have the positive case and the negative case. So when we solve, we get x equals 5 and x equals negative 2. When we plug both back into our original equation, we actually find that both solutions are valid. So sometimes what will happen is we'll get something called extraneous solutions when we're solving absolute value equations. And this is something that we'll see throughout this course. What happens is you'll get solutions that you find by solving the equation correctly. Okay, so all the algebra is correct. But when you plug the solutions back in, you'll find that they don't work in the original equation. And so those kind of solutions are called extraneous solutions, and that's why it's always important to check your solutions when you solve absolute value equations. So here, let's try this example. So we have the absolute value of x plus 10 equals 4x minus 8, and I know this isn't equal to a number, so it's a little bit different than the ones we're used to solving, but since the absolute value expression is already isolated, we can just go ahead and separate it into two cases. So we're going to say this means that x plus 10 is equal to 4x minus 8. And it means that x plus 10 is equal to the negative of 4x minus 8. Okay, so that's how we're going to write the positive and negative case. So I'm going to work on solving this first equation on the left. So since I have a variable on both sides, remember I need to move all my variables to one side. And I can do that by subtracting 4x from both sides. So when I subtract 4x from both sides, remember that the coefficient of this x is actually 1. It's just implied, and so it's not written there. I have 1x minus 4x, so that's going to give me negative 3x. And then I have plus 10, and that's equal to, well, 4x minus x just cancels, and then I have negative 8. So now I can solve by subtracting 10 from both sides. So when I subtract 10 from both sides, I'm going to get negative 3x equals negative 8 minus 10, which is negative 18. Now I can go ahead and divide both sides by negative 3, and that's going to give me x equals 6. So that's going to be one of my solutions. Over here on the right, what I need to do is I need to take that negative and distribute it to both terms in order to solve. So I'm going to get x plus 10 is equal to negative 4x, and then that negative makes this a plus 8. So once again, I'm going to gather all my variables on one side. So here I'm going to do the opposite and add 4x to both sides. Once again, remember the coefficient of the original x is 1. So 1x plus 4x gives me 5x. So I have 5x plus 10 is equal to 8. And then I'm going to go ahead and solve by subtracting 10 from both sides. So when I subtract 10 from both sides, that's going to give me 5x is equal to negative 2. So now what I'm going to do is I'm going to go ahead and divide both sides by 5. And when I divide both sides by 5, I get x equals negative 0.4. So now I have my two solutions, so let's go ahead and check them. So I'm going to start off by checking x equals 6. And when I do that, I get the absolute value of 6 plus 10 is equal to 4 times 6 minus 8. So that's the absolute value of 16 is equal to 24 minus 8. Well, that's telling me the absolute value of 16 is equal to 16, so that works. Now let's try checking x equals negative 0.4. So I have the absolute value of negative 0.4 plus 10, and I'm checking if that equals 4 times negative 0.4 minus 8. Well, negative 0.4 plus 10 is going to be equal to the absolute value of 9.6. And so that's equal to 4 times negative 0.4 is equal to negative 1.6. Negative 1.6 minus 8. So this is saying the absolute value of 9.6 is equal to negative 9.6. Well, the absolute value cannot equal a negative number, right? So this is something that's not true. So when I plugged in x equals negative 0.4, I got something that's not true. So that means this is going to be an extraneous solution, okay? If you go back and check all the algebra, you can see that we did do it correctly. So that is going to be an extraneous solution because it doesn't work in the original problem. So in this case, our equation is just going to have one solution, and that solution is going to be x equals 6. So now you can go ahead and pause the video and try doing this example on your own. So here in this problem, there's a few things going on because the absolute value expression is not isolated. So first you need to isolate it. So I'm going to subtract 6 from both sides, and then I'm going to divide both sides by 2. So once we do that, we get the absolute value of x plus 2 equals 2x minus 5. And when we solve these two equations, we get x equals 7 and x equals 1. When we plug them back into the original problem, which is written right here, you can find that x equals 7 does work, but x equals 1 is not going to give us something that's true, because when we simplify this, we get 12 equals 0, which is not true. So that means x equals 1 is going to be one of our extraneous solutions. So now let's try solving this problem. So here we have another absolute value equation. I'm going to go ahead and isolate the absolute value by subtracting 8 from both sides. So I get the absolute value of 3x minus 2 is equal to 1 minus 8, which is negative 7. Okay, so this is an important problem because notice this is equal to a negative number, okay? The absolute value cannot equal a negative number, so this is going to be an equation with no solution, okay? So there's no separating into two cases, there's no solving for x. The absolute value cannot equal a negative number, so this equation will have no solution. So remember, absolute value equations can have no solutions, one solution, or two solutions. When you're solving, you need to plug in and check your solutions to verify that you did not find any extraneous solutions.